issue with fire is it is dangerous, and you can't do it everywhere. So my inspiration I wanted to have something that I could use and perform with, because I've been doing this for so many years. I wanted something that could be used in a more, diverse array of situations. And so this is typically this is an exposed image of what somebody doing this art looks like. This guy has color-changing LEDs on the end of some strings, and he's twirling them around. Well, that's really cute, and that's really quaint and all, but I'm an engineer, and Bharat and I know how to do way more cooler things like that. So we decided we should really bump this up a notch in complexity. What if we put more LEDs on this thing? What if we put on enough LEDs, each color changing, each individually addressable, so that we can finally control and output what is going to be displayed when you wave this thing? What this does is it relies on a phenomenon called persistence of vision, and you've all seen it. It's where you see lights, trailing by the light trails, even though it's already passed. Well, that's how these things operate on. You can see the image that they leave behind just because they're moving so fast. So what we wanted to do is we wanted to create a device, which is what we have here. We've created a device that has a row of color-changing LEDs, and what it does is it's programmed via processing. Processing is an image processing software. So we start here on this Mac, and we feed in different JPEGs of a certain pixel height and pretty much any pixel width. And we can send in any image that we want to. What that does is it breaks it up into its component parts. It can read each pixel, find out the RGB values of each of it, and then it sends it via Bluetooth to a mini Arduino that we have running on board on our image processing LED wand. That's all. That's pretty much the basics of the functional operation. Bharat, if you want to talk a little bit about the hardware.
All right. So some of the problems we came into this when we started working on this project was, how are we going to connect 40-something LEDs, color-changing LEDs, each needing its own pin to work with on the array. So first we went with shift registers, because each and every shift register we connect to an Arduino, all we need is 3 pins from the Arduino, and we can connect as many shift registers as we want, so we get an infinite number of pins. The problem is, though, as Dane explained, this is a persistence of vision project, so the LEDs need to be refreshing really fast. This is not something like where we use a TV, where the refresh rate only needs to be 60 hertz. This right here, our refresh rate needs to be close to 2.5 kilohertz, which is essentially the image is refreshing on our LED at once every 2,500 times every second. Sorry. So we started off with the shift register, tried to control 8 LEDs. Then we went on to make a massive wire prototype that was really fun. But again, another problem we faced was we were trying to use it with the regular Arduino 80 mega chips, which are great for most of the projects, but for what we are trying to do, it's not fun. So what we ended up doing was we looked around and we found this thing called a Teensy. Now, a Teensy board is essentially an Arduino compatible board, but it runs at 48 megahertz and has about 16 kilobytes of RAM. Now, that was great, but we are trying to push in huge amounts of pictures with infinite width, and 16 kilobytes of RAM is not enough. So we upgraded ourselves to the Teensy 3.1, which has 64 kilobytes of RAM and runs at a 72 megahertz processing rate, which is what we are running on our onboard processing right now. But that was only one part of our problem. The second part is the LED driver chips themselves. Now, as I explained, the 748C595 is not the best when it comes to refresh rates. We needed something that was as fast as what I described. And after a lot of research and painstaking research and
trying things out
and a lot of money, we found the WS2801 LED driver chips. Now, the beautiful thing about these is these things refresh at a 4.5 kilohertz rate, which means they refresh 4,000 times a second. And all it needs is 2 pins from our resident Arduino. Right now I call it a teensy. And we are able to achieve persistence of vision via Bluetooth using processing. And Dane here will give you a demo of it.
So this was a pain in the butt. That first circuit we made, we tried so many different things. You know, when we first turned this on, we were like, okay, let's start waving it. Let's change the colors. It looks great. It starts flickering immediately. But finally, we came across these. We ended up purchasing these online and made a retrofit. This one, we were working so hard. We were really close. We were working in the IT shop, just getting the hardware and the final touches running, and our Bluetooth module cracked on this one. So this is going to be a demo of sort of the individually addressable things that this can do. You got any, colors on here. It's completely changing. It's changing all the time. Completely persistent. It does not drag. If we were using the shift registers, you'd be seeing blinking all over the place. And that's what we found out to our great frustration after we had spent 24 hours trying to actually make something like it work. Now, I wish I had the other one of these because I could actually start spinning these around. And this is the actual Bluetooth one. It's a standalone unit. I'm going to turn this on.
All right.
It's going to start receiving an image from this computer. So what it's doing is we have a couple images loaded in here. Can't really tell what this is because I'm not moving it yet. But what it does is it breaks down the image and then it plays it one row at a time, and then it repeats that image after we have it downloaded in. So let's see what we can do. Let's see if anything interesting out of here. Let's play YouTube or IoT logos.
That's now doing YouTube. Yeah, you lost it.